In this video, we're going to start talking about area. We're going to look at area of rectangles, parallelograms, and at the end of the video, you want to make sure that you can apply the area formulas to solve some application problems. So that's the overall goal that we want to accomplish. So let's flash back here and talk about perimeter and area in general. So what is perimeter? So if you remember, perimeter is the distance around a figure. So if you were to walk around a figure, how far would you walk? And we use linear units, okay, like centimeters or inches or feet, so linear units. And then area is literally the number of square units contained by a figure. So we're going to divide a figure into square units. So if the dimensions are in inches, we would divide it into little squares that are 1 inch by 1 inch. So our units are square units. Square units like centimeters squared, if we divided it into little squares that were 1 centimeter by 1 centimeter, or inches squared, or feet squared. So always make sure you include your units. Alright, and then last time in class you were reviewing area of square and area of a rectangle. So how do you find the area of the square? So given length of sides s, normally we use the variable s for the length of the sides, the area of a square is equal to s squared, or s times s if you prefer. And then how do you find the area of a rectangle? Given side lengths L and W for length and width. We could also use base and height, or B and H. Then the area of the rectangle would just be length times width, or if we use the other variables, the area of the rectangle would be base times height. Again, the variables we use really aren't that important. It's just, you know, using whichever you're comfortable with. Alright, so let's use this sketch below to calculate the area of the parallelogram. And then we're going to add linear dimensions to the sketch. And we'll use each grid unit is 1 inch. So obviously not to scale. So one way we could find the area of this parallelogram is simply to find the number of squares. So we could just add them up. So this would be 1, 2, 3, 4, 6, 8, 10, 12, 14, 16, so 16 full squares. And then if I put together this little piece here and this larger piece here, that would make a full square. So that's 1, 2, 3, 4, 5, 6, 7, and 8 more, plus 8 more. That would give us 24 inches squared. Now, obviously we're not going to do this for every parallelogram. So let's take a look at the base here. The base is 3 inches. And then let's also take a look at the height here. The height, if we count it off, is going to be 8 inches. And we can see that the area of this parallelogram, if it's 24, we could get 24 by doing 8 times 3. So 8 times 3 which is also 24 inches squared. And if we use this to come up with a formula over on the next page here, we can see that the area of a parallelogram is the same as the area of a rectangle. So area of a parallelogram is equal to base times height. Now, make sure that your base and height are perpendicular to each other. This is important. So base and height must be perpendicular. All right, go back to your vocabulary sheet as well if you don't remember what perpendicular means. All right, so that's it for this video. If you have any questions, make sure you ask, or if you want to rewatch, do that as well. And we'll see you next time.